This is the tutorial for Flow AI. We're starting the tutorial in our dataset with the example data included with the tutorial. And we have the three files named B cells 1, 2, and 3. And what I've done here is to create a workflow. And in this workflow, I just have a figure set up and I've created a Flow AI task, but I haven't edited it yet. To illustrate what these files look like, we can open up this figure. And the purpose of Flow AI is to find anomalies in data, kind of like the ones that we have in these files. So you can see that we have issues with fluorescence intensity changing at different times, just the signal in general maybe dropping off, right? So these are the types of things that we don't want to make it into our analysis, and the types of anomalies that Flow AI is designed to detect. So without further ado, we will learn how to configure our Flow AI task. When we open up Flow AI, the first thing that we'll want to choose is our files. And so in this case, we're going to choose all three files to include in the analysis. And the next thing that we'll choose is which features or channels we want to include in the analysis. And so in our case, we do want to look at all of these parameters to find anomalies. So we'll choose all of them, and paying close attention to the fact that we're not going to be analyzing time in the same way that we're going to be analyzing these other channels, but we will be using time as a support channel for all the rest of these channels to be analyzed. So it's always important to choose time. Flow AI cannot be run without the time channel. The next option that we have to choose is which anomaly detection method we're going to be using. Now this is really the methods that Flow AI is based on, and there's three core options: FR, FS, and FM. And these are names given by the Flow AI algorithm to denote flow rate checks, signal acquisition checks, and signal dynamic range checks. So what flow rate does is it looks at the, intuitively, flow rate of the data in the FCS file per unit time, and it tries to remove anomalies, either surges or drops in the flow rate. What signal acquisition looks at is it actually looks at the parameters that you've chosen over time, and it finds anomalies in the signal during that time. And it does a lot of other fancy logic and ultimately finds regions of the data across all channels that are smooth and don't have anomalies in them. And then the last option, dynamic range, looks at the dynamic range of the signals in each channel, and it removes positive and negative outliers. So extreme data values, it looks to remove those. It's common to choose all methods, but as you grow to have a better understanding of this algorithm, you can choose either an individual method or different combinations of two methods at a time. For this example, we'll choose all methods. The next thing that we'll choose is our time channel. And this is important to note that you have to choose it here first. Again, we're always choosing the parameters that we're choosing here. If you don't choose it here, it won't appear in this menu. So choose time and then choose it here just to confirm that we do in fact have the correct time channel for you. The rest of the methods, you'll notice, all have FR, FS, or FM prepended to them. And that's just to denote, given all these settings, they actually only correspond to certain anomaly detection methods at any given time. So if we were to do an analysis only with FR, flow rate, then only the FR settings would matter. But in our case, we're using all methods, so all these settings matter, and they just remind you with these two-letter abbreviations which detection method they correspond to. We can now turn our attention to the rest of these settings, but given that the settings require a bit of nuanced discussion and a fairly close understanding of how the algorithm is working, we'll simply defer you now to read the discussion in the written documentation as opposed to listening to us enumerate the settings and talk about them in detail. That would add quite a few minutes to this discussion. So again, reference the written documentation, should be acceptable for understanding each of these small detailed settings. And for now, for the purposes of this demo, we're going to keep the default settings, and once the settings are configured, we can go ahead and run Flow AI. When Flow AI is processing, it will put off logs just like any other algorithm will. And upon its completion, we can review these logs if we haven't already, make sure no errors or anything like that happened. And then we can turn our attention to the results. Now, the results for Flow AI are two separate major components. The first is these reports, and the reports will be listed under the generated files organizer in the results. And they'll be broken down based on every single file that was run through the analysis. And each file will be analyzed on its own by Flow AI and will produce its own report. And these reports are HTML documents, so you need to download them and then open them in a web browser in order to view them. And we also have this mini report, which gives just the most basic information about each file, organized as a single reported document. For now, what we'll do is look at the results for this file. Okay, so we've opened up our Flow AI report just for the B cells 1 file, which is the first file in the analysis. We can see at the very top of the report, we're getting information about this file, and we're also getting information about the file in context of the others in the analysis. So we know that we included 3 files in this analysis, and we can see them all represented here. And we know which file this report is dedicated to based on this blue colored bar here in this graph. The next thing that we can turn our attention to in this report is a basic summary of which anomaly detections were used and how many anomalies were removed from the file and how many events that left us with. We're then going to be looking into each individual method that was used for analyzing these data within Flow AI. And we'll point out that every report from Flow AI will always have all 3 anomaly detection methods used and reported, but it's based on your settings for which is actually used to formally reject data points. So the information will always be here and will always be reported to you, but it won't always be used to actually reject the events. So the flow rate check is fairly simple to interpret. It just looks at flow rate as a function of time, and this will also be based on your settings for what your binning resolution is. So 0.1 is the default, which is 1/10 of a second, and any anomalous regions are highlighted in green, and those will be the ones that are identified for rejection. And so you can see here the flow rate drops off significantly, or spikes and then drops off, and then most of the anomalies are found and removed from this area. The next method to turn our attention to is the signal acquisition check. And so what you'll see here always in the results is a single contiguous region of the data, and it could be at one end or the other end, or it could be in between. And this is based on the settings for this actual analysis method. And the yellow region is what highlights the region that is considered high quality, and it will end up matching across all channels. So depending on your settings, this could be a much smaller region or it could be larger, it just depends. We also have basic information here about the change points that were detected. So for more information on change point analysis, you can look at the written documentation, and this is organized by rows and columns. Right now you can see that based on our settings, only 1 change point was detected. But if more had been detected, and that's also based on the data and our settings, they would be listed here as columns. The last method to turn our attention to is the dynamic range check. And the dynamic range check isn't as immediately obvious in terms of interpreting it, which data points are being removed from the analysis. Unlike in the signal acquisition check, which really shows you just your data over time and channels, and you can see the yellow, which is what Flow AI ends up passing, and the rest is rejected. And same here, you can see exactly what's rejected and passed. This plot only really tells you about, on average, where are the events being rejected or passed. And so then we can also turn our attention to this final representation of information, which is for the dynamic range check, we have the lower boundary and the upper boundary, and it tells us how many events are being rejected in each of these. So for example, we can see based on APC size 7 that 110 events are being rejected as being too negative, as in they're considered a negative outlier. And for the positive outliers, 16 are being rejected. And we can see the behavior of this analysis on each channel, and then we can get the totals. The second category of result is the flowai-passed channel, which is added here to the files. And to view that, what we'll actually do is go and create a gating task after the flowai task. So you can see that it goes flowai and then gating. And if we look at that parameter, flowai-passed, we'll see that there's two values. And we can look at the values encoded as any sort of plot. And one of the values is 0 and the other value is 1. And what 0 means is that flowai decided that these data points should be rejected. And what 1 means is that flowai determined that these data points would pass the analysis. And so as you're probably used to from other forms of analysis in OMIQ, we can grab these encoded values by way of using categorical filters. And so one easy way to do this would be to just choose the flowai-passed channel here, and then just say, give this a prefix of flowai. And then we're going to get values 0 and 1. And then if we want, we can easily rename these to, for example, flowai rejected. And the second one could be flowai-passed. And so now we have an idea of which data points were passed and which were rejected, and we know the statistics. So we can go ahead and save that. And we'll navigate back to our workflow now. And what we have is our original figure and our flowai task, and now it's followed by gating, where we actually categorized just the flowai-passed and flowai rejected data points. From here, it's up to us what we want to do, but probably the first thing we want to do, just for demonstration purposes, is let's make a figure and investigate what the effect of the flowai was. One way to do this is just by using simple plots, and we could use overlays, or we can just keep it simple and use individual scatter plots. The first thing that we'll want to do is set the x-axis to time, which is what we did earlier. And for helping us evaluate these, I'll also turn on the file names and the filter names. So the first thing that I want to do is evaluate the difference between unfiltered, and I'll permute these to also look at flowai-passed and flowai rejected. And I'll put these in new rows. And so now what we're looking at in the top is our raw unfiltered data. This is the events that flowai decided were clean and passed on to the rest of our analysis. And then here's the events that flowai rejected. And so we can see that actually flowai does reject events from within what would otherwise appear as a pretty clean part of the distribution, but it definitely heavily rejects events to the right after this disruption, this clear disruption that we have in the acquisition. And so we can also perhaps understand better why these events get rejected by looking at our different parameters of interest. And so we'll now choose those, not as the x-axis. We'll choose them as the y-axis, and we'll get rid of those two parameters. And so now we're looking at this figure, and I'll zoom it out a little bit. And so now we're looking at all of our parameters as the y-axis changing in each column. And of course, we're looking at our three states of unfiltered, flowai-passed, and rejected. And we can just understand in different parts of the continuums of all of these channels, which data points got removed versus kept. And so this is a great figure to look at in terms of informing that understanding. And then of course what we can do is also make this figure we can either change the figure such that it's looking at the different files, and we can interpret that one at a time. Or of course, we could expand this figure using permutation to also incorporate these other files, and we'll put those in new rows. And now we've got quite a big figure here, where each of these 3-row blocks looks at a different file. After this, we can decide what we want to do next in our workflow. And the way that we'll do that is simply by going to gating and then making sure that we choose the subsampling task. Now, the subsampling task actually allows us to subsample our data according to some sort of filter. And so this step is crucial for actually deciding that we want to accept these flowai-passed events and actually take them forward in the analysis. So we can go ahead and max out those and change our sampling however we want. But now you can see that we are in fact subsampling these data. So we'll save. And now anything south or downstream of the subsampling task, so for example, if we made a plot here, we'll actually see that this plot is going to have only the flowai-passed data points, and we'll recognize that this is the clean section. So again, that subsampling step, as you already know from your OMIQ experience, is key to actually take one of these filters that we have available and actually subsampling it, and actually subsample it within the context of the workflow.